Thank you for the invitation and the opportunity to present in the status of Invest4Nature here. As I was informed, you heard several times of the progress within the project. So we'll give a brief update what has happened during the last month. So several deliverables, which are very central to the project, are now finished. And might be also interesting for you. And I will also give a deep dive example. So we did several deep dive cases within the project to evaluate the insurance value of different case studies within the project. And for one example, this is for the river of Lech in Tyrol. I will present our results so far. And yeah, please interrupt me if you have any questions or feedback, and I'll be happy to discuss it. Yeah, like Naturance, the project is also in its last year now. So you know the partners, CMCC, Jaro, and Andrea did a lot of contribution within the project, are also central project partners to us, and were heavily involved in the deliverables I will present afterwards. I don't present the aims again, just to remind you a little bit. We have 5 different case study areas. This is Norway, Austria, Denmark, Poland, and Portugal. And the structure of the project was to tailor this all NBS interventions, evaluation topics on different landscapes, because different landscapes have different co-benefits and different environment, which has to be taken care of. So the different environments are coastal and fluvial, mountains, urban, and forest, I think, and these different topics were tried to answer and to tailor the developed frameworks within the projects to these different landscapes. The deliverables which are finished now, which are the central ones, I think, within the project, 2.2, 3.1, and 3.3. So 2.2 gives an extension of the total economic value framework, which was tailored to nature-based solutions, and integrates the insurance value in a more or less systematic way into this concept of the total economic value framework, and also presents some methods which are suitable to capture this risk and insurance topics for NBS projects. Then deliverable 3.1 is presents results on the deep dive cases, but also the results of a very comprehensive meta study on evidence on cost benefit from NBS projects, which was also structured according to the landscapes I presented before. And the last one, the task work package deliverable 3.3 is about market and financing incentives of NBS, where stakeholder interviews were carried out and to collect the different hurdles or perspectives according to financing and markets for NBS. So the last one is also already published, but the other 2 ones are not published yet, but will be published soon, but they're submitted to the EU already. Yeah, if you like, you can also, you will see it in the social media when they're really uploaded and accessible to the public. So the thing we were talking a lot about within the project is this total economic value framework, which is already well known from the literature and is developed since the 70s onwards. And what we did in a stock-taking exercise in the first half of the project was to collect all these different methods and to structure it to match it to the different landscapes and NBS projects. And we also gave an overview about the single methods with their benefits and disadvantages. and this was also thought as a guidance for practical for the practitioners where to find the most to make it easier to find the most suitable method for their MBS project, and to give a comprehensive summary on that topic. We also used the ecosystem valuation database to try to measure the relative importance of the different methods according to different landscapes and MBS projects. So there you find, for example, if you have a forest, then the market price method is important to measure the provisioning of timber, for example, for this landscape in this context. And this was used 70% of the times within this landscape, for example. So this should give practitioners good overview and what is important in which landscape and which NBS project. Within the next step was to further develop this total economic value framework to integrate the topic of insurance value. And this was a lot of work done by Andrea, who finally proposed the structure of this diagram. And what we tried to do is to define what means insurance value for us according to nature-based solution, and to broaden up the concept, not only to focus on the classical point of or definition of insurance value, where you talk about the insurance industry and insurers, but also other aspects which are important when you're talking about insurance value, like the protection of nature, and not only the protection by nature, for example. Where also the protection of nature is important to ensure the functionability of the ecosystem, so that they are able to produce their ecosystem services to the society as well. And then we divided the different methods which are important from our point of view in this topic into data-intensive methods, less data-intensive methods, and participatory methods. And some of them we used within our deep dive cases. For example, the value at risk method, which I will also present later in the Lech deep dive case, but also insurance value and Bayesian neural network were used within the deep dive cases to give an example how these methods can be applied. This is the definition of the different classes of insurance value. Protection of nature is the protection of nature itself that they be able to deliver the ecosystem services and the ecosystem stability. Then the protection by nature is the more or less classical mitigation of damages part. Then social resilience means that you also get social stability by delivering social important benefits from nature-based solutions. And the ensuring future part is more or less the that it's the ecosystems are able to deliver this in the long term. Also within this DEV framework, stepwise assessment procedure is within this deliverable also a little bit tailored to practitioners within the different frameworks and publications. You find different assessment procedures for nature-based solutions, but this one is also thought to go until to the investment strategy and to give a special focus on insurance values for nature-based solutions. What I already mentioned before, this is the meter study did within the work package 3. This was very comprehensive. I think about or more than 1,000 papers were screened to get values on cost and benefits out of evaluations. And this was structured also by these landscapes, and cost benefit ratios were calculated for different NBS actions. Here I took the table for the urban environment, and you see, for example, for the creation of new blue spaces, you get the mean is the cost benefit ratio. You get a cost benefit ratio of 6.3, where it's the benefits overweights the costs by far. And new green spaces, for example, 9.7. Here you get the highest cost benefits ratios I saw, but there are tables within the deliverable for all landscape we investigated and give a very good answer on what is most valuable in realizing NBS projects. As I mentioned, we did several deep dive cases to apply these risk evaluation methods. And one is the deep dive case for the Lech River in Tyrol. This is an alpine river. Here you see a picture of it. It's not a very dense populated. So it's a rural area, but you have also a lot of some settlements along the river. And this has also some touristic importance. It's approximately 65 kilometers long and have 40 square kilometers, and was an Natura 2000 area since 2000. And the difficulty for us was that not only a single measure which could be characterized as an NBS intervention was taken, what we can focus on, but there were several different measures which extend over a long period of time. So the first measures were taken from I think it was 2001 onwards, so the last 25 years, where renaturation measures were implemented to preserve and restore natural river habitats, for example, but also to improve flood protection and to raise the awareness among the population on biodiversity topics. And for us, it was very difficult to get hold of this topic, because on the one hand side you have this long period of time, and also where if effects of the NBS interventions are overlapping each other, or maybe some of them just have an effect for some time and then this effect vanishes. But also it was very difficult to get necessary data from the different measures. So we had a lot of workshops with the local authorities on data and how to collect data on the measures, but they weren't able to extract the data from their recordings. So they have a lot of things on paper in their cellar, and then had no one to dig the information out, and it was too cost intensive to dig deeper into it. And therefore we decided to pick one of these measures. This was the bed load trap, which was implemented 2017, and to demonstrate this value at risk approach according to the bed load trap, where we know that 300 houses have been protected by this measure. We also tried to measure the tourism effect of the single measures, and there we extended over a longer time because the tourism statistics are available easier.
What is the bed load trap?
I will present it. Yeah. We also tried to use existing flood zone data. We have several data sets of them, but the the difficulty is that they are not comparable directly to each other. So we have two data sets, for example, from 2011 and 2021. And first we thought they are good because we can use this as before and after data set, but they have so different methodological approaches in the measurement of these flood risk zones. They are such that they're not comparable with each other. And on the right-hand side, you see this it's a data set on flood risk zones from the hazard plans, and they should be the best one and the appropriate ones to measure the real flood risk, because the other ones are Austrian-wide results, which are not suitable to, which are in aggregate on an aggregate level, right, but not in a very detailed level. On a local topic, you have some problems within the dataset. Yes, and therefore we, flood risk modeling would be necessary to answer this for and after, but this wasn't within the project to do that. In the Portugal, in Cascais River, a student did flood modeling, but for the Lake River, it's too complex because you have this gravel transport within the stream and have more complex dynamics therefore. As I said before, the bedlock trap is designed, it looks like this, and the idea is to have a bypass for the mainstream. So here you see the mainstream of the Lech River, and you have a blocking building to regulate the amount of water which goes through the mainstream, and on times of heavy rainfall, when the water flow exceeds this amount, then also this bypass is flooded, where the water speed is decreased such that the gravel lands here. And is not just some amount is transported through the mainstream, which is acceptable, and the excess gravel lands here in this part of the valley, where it can be removed by the road, and it is not necessary to remove it directly in the mainstream. So it's to be real, it's a combination between a nature-based solution of the bypass and a gray solution. Like we often saw this combination of two elements. But this gravel deposition is on the one hand side a new ecosystem for some species, but also makes it easier to harvest the gravel and to that the gravel doesn't land in the mainstream, which rises the flood risk for the downstream regions. For our modeling, we used these flood risk zones, which are available for 30, 100, and 300 years. And then we used a statistical model and a Brown-Resnick process to interpolate this data and to estimate the expected damage for a given frequency. There we decided to calculate the 200-year value at risk, which is also used as a solvency criteria for the Solvency II directive. The value at risk is represents the tail of the expected damages, and says every 200 years you have to expect damage in this amount. And this is also the criteria as defined to hold reserves for the insurances for this 200-year event. We created a building stock for this region and used these 300 buildings for the flood risk reduction and calculated damage before and damage after, and got a reduction in damages about 80,000 euros of the yearly average of this flood risk damages, and we have this building structure defined by the different building types which are inside the flood risk zones. But we assumed that the distribution across these different building types of these 300 buildings is the same than in the flood risk zone. So we didn't knew which buildings are exactly saved by this measure. And then based on this Brown-Resnick process, which gives us also the regional interdependencies on the level of municipalities, we calculated on the one hand side the value at risk for the municipalities at the Lech River alone, but also the value at risk for an Tyrolean-wide flood risk insurance system. This dependency structure gives us the probability that flood risk events happen in the same year in different municipalities. So, for example, when a flood risk in the Lech Valley arises in one year, how high is the probability that also in other municipalities in the same year flood risk event will occur? And this interdependency structure is calculated based on the data of the different streams and how the rain events spread across these different streams, and gives this dependency. And our results show that for the value at risk, which by this measure was lowered by 4.2 million for the Lech River, but only 1.9 million for a Tyrolean-wide insurance system. And this shows us a pooling effect of the risk, because the aggregated risk of a pooled risk is smaller than alone, and this shows that it depends on how large your insurance system is. You get a different amount of benefit out of a nature-based solution. And this we interpreted this reduction in value at risk as an additional source of benefit, where you have to hold less than before on reserves for the insurance or for the insurer, and this lowers the opportunity costs, but also the financing costs with this money. So this was my deep dive. We also did deep dives for other case studies, but I didn't have it here now, but will be accessible in the deliverable. But I think the Qashqai's case is more in Naturance Valley, and the other one is about Bayesian belief network in Norway, and the last one is about value transfer application.
Thank you, Michael. This is really interesting. So I think there will be some questions. So I would break the ice perhaps with the discussion. We had similar case with the wildfire. In wildfire, it was not clear what is the nature-based solution in the wildfire sort of control mechanism. And I guess you have a similar problem here with this bed load trap, right? So it might be a nature-based solution, it might not, right? It really depends on the wider context in which it's operating and what is the final purpose. So can you perhaps share some ideas about the discussion, how you determine that this is a nature-based solution and what kind of discussion led to that?
I'm not an hydrologist, but as I know, the classical type of bedload traps are like very large concrete buildings where you have this landing before this trap where you have a metal net to collect this gravel. It's a more very massive concrete installation within the stream, and this one is still opens the stream itself, so it's species can pass through it, but also you have this widening of the riverbed and this gravel deposition. But we discussed this topic a lot about the definition, what is an NBS solution and what is not, and where are the where is the border between it. But yeah, we decided that we see it like this also within the all other interventions within the Lech Valley, because it's less massive intervention than which is usually.
So you might call this working with natural processes, rather than, if you wanted to be picky, a nature-based solution. But it's judo is what you're doing, is you're using the power of the river to dissipate the flood. If you wanted to make it a true nature-based solution, you'd fell a couple of trees and put them across the river and replace the bridge. No. That's what they do in the UK and in the US. So you just use woody debris to create the same effect. So there you go.
Guys, who would like to? Yeah.
So I was wondering, it's kind of impressive the amount of data that you collected for this. And I was wondering, did you get a feeling of how much data you do need to get the conclusions that you got? Can you simplify for other cases where you don't have as much data, and which are the really necessary points?
For the flood risk, effects, but it's very cost intensive and often not available, and yeah, there is no solution for that. So within the projects, they have to sign this approval for the single measurements, and there also some evaluations are inside in the project development. But there it would be good to make it easy accessible and to have it digital available. So this would make it easier to evaluate such projects in the future. To collect building data and to do this damage, or to estimate the damage function isn't the difficult thing. It's more or less the hydrologic model, which is a keystone within this evaluation. Yeah, please.
Yeah, this is super interesting work. Do you know if the insurers in the area are willing to actually recognize these reductions in risk in order to adjust their premiums? Like, are they taking this into account, or is this kind of the start of the process to say, look, there are these reductions, and at some point down the road that this will actually be affecting things, or is it? Are you in discussion with them at all on how they're looking at this?
To start the discussion, but the insurance sector is very traditional and sometimes intransparent, and often takes a long way to change things, and they have the internal procedures how to measure risks, and they don't give an insight how they do it exactly. So I think it's minor steps to start the discussion, but it's a long way to generate a real benefit stream where you can finance nature-based solutions. But I think it's also a good way to propose these case studies and to show that it makes sense. And for single measures also to get the local population on board for such projects. It would be a nice additional element of such projects to give some of this money back to the region, for example. Because what we learned about the Lech River, these measures aren't very welcome for the local population. They have different problems, and they only see the loss of arable land, for example, for the widening of the river, and therefore some ideas of the benefits are also good. Maybe insurers can give back to the region. Mm.
Yeah, thanks. We used to do some very similar things here at IIASA on using the Monte Carlo simulation and different models, and also some cost-benefit analyses, which we do in the developing world. One of the things we ran into in doing CBA1 is the uncertainty around a lot of these estimates. And so we try to kind of put some uncertainty around our expected losses. And so the second thing was the discount rate, because this benefits people way into the future. And of course, the third thing, of course, is taking account of the climate change. So we tried to do a sensitivity analysis around the discount rate. I wonder if you take that into account when you do your CBA, or are you?
Yes, not in. Yes, but not in this case. We are not at the final end for this estimation. So this is an yeah, but these topics are important, as you said.
I was really interested in some of your previous slides where you had a lot of the methods listed, that you could use. And I think I'm not sure, one was, I think, as you move forward with, if you have less data or if you have less analytical support. And I think this is one thing we're facing if you go into different municipalities, looking at some of the things they can do for climate adaptation, that they don't have the kind of analytical power or the data. I mean, I'm personally, I sometimes think no analysis is better than bad analysis. And so I get very skeptical if you just use some subjective estimates and so on, that you may have very misleading things. But, have you thought about that at all? How what might be robust, but to do with less analytical work?
Perhaps I can take it. The point that Tim has mentioned. Excuse me. I think in Austria, it's rather straightforward to implement the connection to the insurance, right? Because you have these catastrophe funds, that is a levy on personal income, and half of the revenue is used for risk reduction. So it's public money, basically. And as soon as you have the evidence that you are doing something that is reducing the damage, that should be fundable. So it's rather straightforward to establish that. Of course, the commercial insurance might exist in Austria. That would be much difficult, but for the public part, yeah.
Well, thanks a lot for the presentation. It's very interesting, I think. All the all the information you collected. That's the ghost again, or did I cause it? Yeah, so I was curious what the next steps of your analysis are, because you start with this broad valuation framework that includes co-benefits. Are you also considering to kind of add that to your risk reduction analysis later on to look at the societal desirability of these measures, or was the analysis really more having an insurance oriented purpose, and are you only focusing on avoided damages?
On the one hand side, it was to demonstrate the method for this type of project. But also we had 4 main streams of benefits for the Lech River, which was the gravel harvesting, where you can use the gravel to for construction, for example. This is very straightforward. You only have to multiply the amount of gravel with the price. Then you have the tourism effect along the valley, and therefore we have a different model which we are developing, but it's not finished now. We develop a statistical test for significance now. This is a panel approach with also bootstrap modeling to calculate the value at risk for the tourism. And then we have the flood risk benefit, and last but not least, the biodiversity benefit. And there we saw our first idea was to evaluate all 4 benefits and then to aggregate it to this total economic value. But what we saw that this benefit, this biodiversity aspect wasn't originally planned, because we would need a huge process to evaluate this, and therefore we only focused on the first 3 parts, and this 3 what we want to aggregate to give a total amount of total value based on this 3, but not on the biodiversity part, which is very difficult to measure, where you need some contingent valuation approach, which is very cost intensive as well.
May I just follow up for how do you attribute the impact of tourism specifically for only nature? Like, because it could be that there are other factors around it that can also influence why tourists choose that area to go, and I think that's sometimes a bit this attribution problem a bit tricky. Do you also?
Yeah, it's difficult. Along the valley, a lot of different measures were taken, and also some touristic, with this different project, some touristic infrastructure was built, like a cycle pathway, a cycle path, and also for hikers. Infrastructure, and also a guest house within the Lech Valley. And what is not possible is to separate the effect on different single measures, and also we are not able to separate what is the part of the touristic infrastructure versus the nature-based solutions. So we measured them together, but we wanted to build up a method where we use especially data with different frequency and different quality, and to combine this in a single model. For example, to combine the tourism statistics for overnight stays with counting stations of cyclists along the valley. They are daily data, and the other ones are monthly data. And based on this combination of different data, keeping in mind that is often the case, you have different data sources and you want to extract the most information which is in the data, and to get an aggregate result on the tourism effect. But